Good morning, folks. Ready for day 2 of Advent of Code. Yesterday was a bit of a warm up. Let's see what day 2 has in store for us. I am sensing that this year we will have a nautical theme. Yesterday, something about a submarine. Today's title is Dive. I noticed Eric Wassel, the big brains behind Advent of Code, yesterday tweet something about merchandise, and it's all submarines. So I think we'll be seeing a lot of sea creatures, underwater levels, stuff like that. But let's take a look at day 2. So we need to figure out how to pilot this thing. And with this thing, I think they mean submarine. So it seems like the submarine can take a series of commands like forward 1, down 2, or up 3. This is starting to sound like the Mars rover kata. So yeah, we have different types of commands with distances expressed in units, forward, down, and up. So we have horizontal position and depth. Okay. Let me quickly grab an off-screen tab. Okay. So note that since we're on a submarine, down and up affect your depth, and so they have the opposite result of what you might expect. Sorry? Down increases the depth. Okay. So if we go down 3 units, we are 3 meters below sea level. Yes, okay. Submarine seems to already have a planned course, which is our puzzle input. Let's maybe grab that first. Let's get rid of the bookmarks. And let's maybe also prepare a day 2 folder. I had a bit of a rough start this morning. I had 0 time to prepare. That is not where I want this folder to go, but okay. How can I... Okay. I'm just going to quickly copy paste some files from yesterday. There we go. Let's grab the input. So it's a very long sequence of commands for submarine or for our operator. 1,000 of them. Okay. I'm gonna get rid of everything we wrote yesterday. Maybe not the test part. We might want to test something. There we go. Sorry for the slow start today. It's 6 o'clock in the morning when I start these exercises over here, so whew. So we have a planned course. We should probably figure out where it's going, okay? We start at 0 depth, 0 horizontal position. Forward 5 adds 5. Yes, down is 5. Below sea level, yes. Up 3 decreases your depth. Decreases your depth. Okay, yeah, the up-down thing is a bit confusing. So, yeah, this is the Mars rover kata. Literally. We just need to run our commands or a sequence of, what do we call it? A planned course. We need to like run it and figure out how far we get and how deep we end up. And we need to multiply both of them, but let's first figure them out. I'm gonna grab the example just like we did yesterday. So we have a little tiny thing to work with. Comment this. Okay, let's make sure we can read our input first. Okay, it was a bit slow, but we are live. The FSI interactive window sometimes takes a couple of seconds to wake up first time. Okay, we are live. let's already split the example into lines, so it mimics what we have in our file. I have my auto formatting configured, so if you see code jumping around, that's the formatter doing its work on when I save the file. It's a bit slow initially as well. I really need a laptop upgrade. We need to trim the tabs. I'm not gonna bother trimming, I'm just gonna leave some horrible indentation in my code file. Okay, so yeah, maybe some background. I've mentioned the term 2 times already. Mars rover kata. Katas are like little programming exercises you can use to try out a new language or a new framework. And this puzzle today is literally that puzzle. So if you want to dive a bit deeper to like added features, or maybe part 2, it might be mentioned here in the Mars rover kata. But yeah, let's implement this first. So the way I typically, or the way I look at problems like these is we have a sequence of commands we want to run. We call it the course in this problem description. I just take an initial state. We get the initial state right here. Position and depth start at 0, and we just fold over the list of commands. So we do something for every command, and we update state. So this is literally something you can do with a fold. Let's take a look at the function signature first. If my fingers would unfreeze at least. There. So a fold takes a function folder, which takes itself a state and an element of the list and returns a new state or an updated state. And that's the first argument. The second argument is the initial state. And the third argument is, yeah, the list you want to fold over, which will be the list of commands. This will be a nice match, I think, for part 1 at least. But let's first parse our input. We have 3 different types of commands, and every command has an argument or like a step size. So let's write a function to parse a single command. Do we call it commands, instructions? Commands. So let's take that terminology into our code. Let's define a type command, and it can be one of 3. It can be forward. I'm just gonna keep it lowercase to be in line with the... Can it not be lowercase? Probably it cannot be lowercase. Okay. No, it cannot be lowercase. Forward, down and up. Not downcast. Down. Oh dear. Stop trying to correct me. Okay. And up. IDEs are helpful until they're not. And every of these commands takes a number. I'm not gonna bother giving it a name because it's just a single integer. So yeah, we have 3 types of commands, and every command has a step size. Now let's parse a string into one of these commands. Should I? I'm doubting, should I use the match syntax or a function syntax? When in doubt, use the match syntax. So command text is match this given command text with... No, this is literally what you can... Okay, but first let's... Jumping ahead here. So if we have something forward... something, so it's actually... Should we first do a little bit of parsing before we pattern match? Maybe we should. So I'm gonna call it them words. Yeah, so let's split the string into words. Maybe then we need to help the compiler a bit by explicitly mentioning the type of the command text. That way we have everything like split in our IntelliSense or in our autocompletion. We know, or we're not going to handle error cases. We know that words always has two elements, which is the command text, the command itself, and the distance. Let's call it distance. And then we can match on that first thing, the word or the command. And that should be forward, down or up. And then we can parse the distance as well. Let's call this the raw distance or the unparsed distance. And this is the raw command or the unparsed command represented as a string. And let's parse distance into a number. No, raw distance, please. Yes. And that is a number. Raw command we can parse using this pattern match. So it's a forward. I'm also going to put that in a variable. And we have up and down. No, that's not actually true. Can we do this? I'm thinking that you used to not be able to represent or use a case in your pattern matching or without providing it the full data constructor. Like we say here, command is either forward, down, or up, and they always have an integer. But here I don't specify the integer. I'm not sure if this works. But if it works, we can do something like apply the command data constructor to the distance. Does that work? I see a lot of red lines, so probably not. That is a list instead of a array. Cool. I will use array syntax in that case. Whoa, that actually appears to work. Yes, we know we can have malformed input in theory, but in practice we will not. This is non-trivial, so I'm gonna write a quick couple of tests for this. Yeah, let's just try a few tests. So let's try to parse forward 3. What does that give us? It should give us forward 3, right? Yeah, looks good. Forward. Let's just do all cases. Up 2 and down 1. Why not? Or let's maybe take a bigger number. 13. I'm being a bit neurotic and testing everything because with these kinds of puzzles, if your building blocks are implemented incorrectly and you don't notice, you can go on a wild goose chase, sorry, when things go wrong or when you don't have the expected input. So I would rather prevent that case. Why is my REPL so slow? Is it even responsive? No, it is not. It's a built-in feature of the F# programming language. When you live stream Advent of Code Solutions, it's like really slow so you don't violate terms and conditions. Because if you do like speed coding, you're not supposed to live stream. It's a nice feature. Of course, totally not true. Yeah, so that all works. I just write this is like my mini unit test framework. I just write a function with all my tests so I can run them in bulk, but I can also select a single test case and run it in the REPL. So best of both worlds. Anyway, we have a valid parser. So let's work on the meat of the problem today. Run a sequence of commands over a state. State is something I also want to explicitly represent as a type. Let's call it submarine state. And that is not a union type or discriminated union, that is a record type. So we have two properties. What were they called again? The horizontal position and the depth. Everything is non-responsive today. Are we still not dropping any frames? No, we're not. Okay. So horizontal position. And the depth. I'm gonna take a quick look at what's happening because we are slow today. Hello, dear computer. What is eating you? SFC. I have no idea what that executable means. Anyway. So yeah, let's also write a function to build the initial state. Or a variable containing the initial state. When your data is immutable, you can do stuff like that and not have to worry about it being a function or a variable. So we have initial state. We need the folding function now. But maybe let's do it top down. Let's start writing our solve function. So what would our solve function look like? We get the commands, or like the strings representing the commands. And on that commands sequence, we do a sequence.map parse to parse into our actual commands. And we fold over this list of commands. Oh my dear, everything is... Maybe I should restart my computer when doing live streaming. But anyway. And we fold over that list using a folder function and an initial state. And then we need to define our folder function. Do we... Yes, let's write that as a top level function so we can take a look at it from our tests as well. I was thinking of maybe nesting it inside the solve definition so it's hidden to the outside world, but it's a small detail. Folder, what were the arguments again? State and an element. State and an element. So state is the submarine state, and element is a command. And it should return an unupdated state. Let's just now have it return the state it is given. Cool. No, this is actually, okay, becoming unworkable. Every time I save, my IDE freezes up. Not cool. So let's roll out this folder function. I'm not gonna call it folder in here. I'm gonna call it run command, something like that. Or apply. Let's call it apply command. Good morning, Major T. I have no idea what you mean with system file checker, but I don't want to be hacked. All right, let's make a deal. So apply command. Given a state and a command, we have to give the updated state. Let's pattern match on the state, on the command, sure. So if it is a forward, we need to do something. What do we need to do? We need to update the horizontal position. I think so. Yes, and otherwise we need to increase for down and decrease for up, and that's confusing, and we know, okay. So let's use the update record syntax here. So we take the original state with a new horizontal position, which is the original horizontal position plus the new or the provided distance. And we need to do something similar for down. Down increases our depth. And up decreases our depth. So that is a minus. I think we can run our code against the example, and that should be enough for part 1. So let's give it a try. So let's select the code we just wrote. Okay, sfc.exe is a file checker. I love those enterprise software running on your computer. Kind of things that hog up all your system resources. Cool. So let's try to run it on the example. We should get something. I don't know what we will get back. We will get a state back. Let's see what state we get back. Horizontal position is 15 and the depth should be 10. Does that sound correct? That is super correct. Cool. So let's hard code that in our tests for posterity. And depth should be 10. Let's try that again. Oh, it is actually horizontal. I made a typo. Okay. Let's see if my refactor support can refactor F# records. Yeah, it can. Cool. I've been playing with JetBrains Rider. It's almost there for F#. Close, but not quite. It's a good alternative to Visual Studio for most work. Okay, it's running green, so let's run our code on our actual input now, which is in the input variable. That is not what I was trying to do. That was better. Oh yeah, and we need to multiply the 2 digits we get, or the 2 numbers. Let's grab that, put it in a variable. Times and state.depth. And that should be a number that is small enough to not overflow. Hey, there we go. Ready for part 2. I was watching some streams from other people doing the Advent of Code challenge yesterday, and they all have like these frameworks to automatically fetch the inputs and to automatically have a part 1 and part 2 solver. That is very advanced. I'm really old school. I just copy and paste some files. So yeah, let's take a look at part 2. Based on our calculations, the planned course does not seem to make any sense. We find the submarine manual and discover that the process is actually slightly more complicated. Cool. In addition to horizontal position and depth, you'll also need to track a third value, aim. Aim. Okay. The commands also mean something entirely different than we first thought, of course. So down and up is not affecting depth, it's affecting aim. So it's probably an angle. Increases your horizontal position by X units. That's not how movement in units works when you move according to an angle, but okay. It increases your depth by your aim multiplied by X. Okay, so it's not really an angle. It's an approximation of. Okay. Again, note that since you're on a submarine, down and up do the opposite of what you might expect. Down increases the number. Yes. Okay, examples would be handy right about now. Which is the one? Okay, so for down and up, just change aim and don't do anything else. And forward, that's where the magic happens for both horizontal position and depth. Okay. And down and up, they change aim. Down adds to aim. Up subtracts from. Oh, that's confusing. Down adds 5 to your aim. I'm gonna stop reading and start implementing that because I will do it wrong. What changes? The concept of our state changes. We'll need something called aim as well. Let's just keep it an integer. Also starts at 0. And then this part happens to change as well. Oh, come on, sfc.exe. Stop messing with me. Down and up, they don't change depth, they change aim. And down increases aim. So down increases aim. And up decreases aim. And this is where the magic happens. Increases horizontal position. That's what we're doing already. And it also increases our depth by aim multiplied by x. Cool. So it changes our depth by increasing our current depth by aim multiplied by the distance. Increases our depth by aim multiplied by the distance given by the command. Yeah, that's it. That's actually not that bad, right? Let's see if we get the same result for the example. What's the aim in the end? We don't know, so let's just put a random aim in there. We're almost finished for today, so I don't care that these tests break whenever we add a new field. I can live with that. Yep, that's everything we changed. Nope. Submarine state does not define. Yes, I'm just gonna throw everything away because my REPL is getting confused by all the different versions. If it wants to, at least. Warning, warning. Yes, we know about those. Cool. Let's solve the example. Test is not defined because we need to download the NuGet package, correct? It sure adds to the cliffhangerness or the tension. Yes? No? Are we there? We are there. Okay, so we have what's the actual? Okay, so we have 15 and 60. I seem to remember that's correct. Yeah. So let's hardcode aim with 10 because that appears to be the final aim in the example. No. 15 and 60. Okay. Cool. That all works. Let's run it on our example or on our test input, puzzle input rather. And let's multiply them again. I don't understand why I'm typing like ES and it's giving me submarine state as the first hit. Why? Why? That is a bigger number. Are we hitting overflow territory? I don't think so. For day 2. Hey, there we go. Oh, it's a fun. That's a fun exercise. Mars rover kata, with a Christmas holiday submarine theme. Cool. I'll make sure to not have a slow IDE for tomorrow. But other than that, hope you had some fun and see you tomorrow for day 3. Thanks for watching. Bye bye.